Alright, this is going to be the last one we do for now. You need to try to work through this series of steps, remembering coordinate systems, remembering that you can work on a couple different tools at once, and you can have a sheet of paper up here that you're talking about writing down all the matrix, all the rotations of the externals, and then resist them with the internals. And so I'm going to kind of see if I can do a pen erase here and go through this problem. Setting it up, I've got two forces. I've got a resultant of this and a resultant of that, so I'm going to add two matrices, and then I have a reaction of one spot right there, and that's got a distance that we'll see in a little bit. The first thing, of course, we have to do is to set up our coordinate system or keep track, and right there we have to hit enter, and then if we click our mouse over the top, if we set the block reference tooltip up, we'll see that one there is at a distance of 8.35. And so you might want to say something over here right away that this is at a distance of 8.35. In other words, you want to find that force is 8.35 away from this moment arm here at A. Now, that said, you can go to here and remember that the first thing you've got to do is get an area and place it at the midpoint, the centroid, and you can slide that down to line, so you can do a list or a mass prop. In all reality, you would like to put it really at the middle. The area is 9.8 in this case. And what you do is you draw a line from the midpoint of this, you pull it down, make it go 9.8. And in all reality, you should put that on the correct layer, that habit of going into viewport, and that's a force resultant. Now, of course, you can start going through and highlighting and writing up your matrices. So that first one is at a location of 3.95 and 0. So you can go over here. The point of force is 3.95. At a location 3.950, you go back to here. The force is 0 and minus 9.8. So you go over here and you write down 0 and minus 9.8. That moment, which is going to be in the order of about minus 40, right, is the moment of this force about that reaction. In other words, this is spinning this way with that amount of torque. Of course, it has to be resisted here based on that value divided by the 8.35. This has to push back. Now this one over here you're going to see is going to also be spinning this down, and it's going to have to be pushed back, but with a whole lot more. So what do? You go over here. And in this case, many of you are sliding. That's better visual, but I'm not even going to do that. I'm going to take my mouse over the top there. It is 14.90 and 4.37. So I can write this one here. 14.90, 4.37. Again, sometimes it's hard. Put my hand over the mouse over the top. 5.1 minus 4.38. 5.1 minus 4.38. Now you can calculate these two moments, and realizing they are spinning towards the right, and you've got to spin back clockwise, so you're going to have to divide by 8.35 and have a positive reaction. So if you need to do that, do side calculation. Let's do it right here. 3.95, if you turn it on, clear, 3.95 times a negative 9.8. That gets you minus 38.71. Perhaps you go ahead, you probably a good idea, minus 38.71 plus, and then you go through the calculation again. somehow as I move my calculator there, I lose pieces of it. So I'm going to slide this one over here. I take, in this case, 14.9 times a negative 4.36 equals, now that's a negative number, and then I'm going to subtract out the other, so I'm going to say minus 4.37 times 5.1. And once again, you're double checking that you don't blow the signs on this, and that's why in the end you have to solve for the sum of the forces in the end. So we have that number, and that number is 87.251. So you write that down, minus 87.251, and then you can do that plus minus 38.71. That gets you minus 125 equals minus 125.96. That's this reaction going this way, and this one you've got to divide then by force times distance. You take that divided by 8.35 to get the reaction. So you divide this by 8.35 and get a reaction of 15.10. And so your reaction, again, even without looking at the signs, you need to think about sense and realize the reaction here is 15.09. That's the reaction at B to the forces. So you solve for the reaction at B, and now to solve for the reaction at A, you don't necessarily have to go back in there because you know that the distance between them was 8.35, and so now this, instead of being 3.95, it's going to be 3.95 minus 8.35. So you can take 3.95 minus 8.35, because essentially you move your coordinate system right, 8.35. And you get a distance of minus 4.4, so in this case it's minus 4.4. The rest of the matrix is the same, 0 and minus 9.8. Same thing here, you take the 14.9 and you subtract 8.35. You get 6.55. The rest of the matrix is the same. Now, in this case, you're solving for the moment here, and you're going to again react with a distance of 8.35, that distance between the supports that we had talked about before. So now doing the math, and I'm going to pause it. And again, looking at these, this is around a positive number here. And if you think about it, yeah, it's spinning it in a positive direction. We'll see what this one becomes. And then you're going to add those up, divide by 8.35, and get a value for the reaction at A, which you assume is up, but very well could be down. So I'm going to pause this and punch some numbers in and bring that back up after I pause it and bring it back. All right. Plugging these numbers in on the calculator, doing this multiplication minus that multiplication, I get 43.12. This multiplication minus that multiplication minus 50.98. Those turn out to be minus 7.85. And these are separated by 8.35. But if you think about this, radius is in a negative direction going that way. So you're going to turn out with a number that is going to be a little bit different than there. This sense, if you think about it in the end, you can start thinking about sums of forces, but that sense of which way this goes is something that when you're doing this, if you stick with the pure mathematics, it will come out, but you have to kind of look at a general sense. So we're going to take 7.85 or 86 divided by 8.35, 7.85 divided by 8.35, and you get an answer of 0.94. The reaction is 0.94. Now this is at one point where sometimes it's better to not aggregate, because you don't know whether this is positive or negative when you're doing it in this method. I mean, you do know, but the fact is that in all reality, if you add up the 9.8 going down plus the 4.36, you look at these numbers and you realize that this has to be in the opposite direction, because those have to add up to the sum of these two forces, and so you get the sense that this is most likely a minus. In other words, it's going not that way, but then down. Final reality, we'll fix this up one more time. Thanks for listening.